For studying IB chemistry of the atom, there are a few challenging topics. Let's hit them one by one. The first one concerns isotopic abundance. Imagine the following question. Magnesium has 3 stable isotopes, magnesium 24 with an abundance of 78.9%, and the rest of it is either magnesium 25 or magnesium 26. Let's figure out the abundances of the other 2 isotopes. Well, we solve this using a weighted average type setup. For example, we know that the remaining 21.1% are divided between magnesium 25 and magnesium 26. Therefore, 78.9% of it is 24, and the rest is 25 and 26. Since the rest adds up to 21.1%, and we're using decimals, that means 0.211, we can call them x and 0.211 minus x. Plug that through to solve for x, and you find that x is 0.119. See that right there? That means that it is the abundance of magnesium 25. That's 11.9%. If you add the 78.9% to the 11.9%, you'll see that what remains is 9.2%. That must be magnesium 26. Having done all that, you might not be convinced you're right, so it helps to always check. So 78.9% at 24 and 0.119, that's 11.9% at 25. The rest at 26 does add up to 24.31, and that shows you how that total mass is divided up amongst its 3 isotopes. Here's another question. We had a homework problem which told us that chlorine, that means a chlorine atom, it's not diatomic, has 2 isotopes. Most of it is the little atom that contains 18 neutrons, and the other one has 20, giving us chlorine 37. Chlorine always has 17 protons. Now let's predict the mass spectrum of Cl2. Nearly everybody told me the mass spectrum of a chlorine atom. They just gave me a big Cl at 35 and a little Cl at 37. It's not asking for that. It's asking for diatomic chlorine. That's Cl2. Now, it's going to be, what, around 71-ish, right? The average atomic mass is 35.45. But since the physical properties of isotopes can be easily separated, the mass spectrum will show all possible combinations of each isotope. So we could have a little with a little, we could have a little with a big, we could have a big with a little, and we can have a big with a big, meaning that you should see 3 peaks, 2 of which are redundant, right? One of them is the 2 small isotopes combining to form Cl2, two different combinations for the big with the small to give us a molar mass of 72 grams per mole, and finally the big one with the big one. To calculate the relative abundance of each, just multiply it by their individual abundances. It sounds weird, but here's how you do it. In other words, I hope you can see this, the A may be chopped out, but you can say that the abundance of the little one will be 75% times 75%, which means it's 56.25% of the sample. So you'll get a biggest peak at 70. For the little one, we have the combination of 0.7 for the medium-sized one. 75 times 25 plus another one that's 75 times 25 gives us 37.5% of the sample. The rest will be the 74 peak, the big one, which is that other combination, which both the 70 and the 74 are less common, but this would be 25% of 25%, which is 6.25%, giving you a chlorine, that's Cl2 mass spectrum that looks like this, 70, 72, and 74, with about a 9 to 6 to 1 ratio. And these exact percents correspond to that sort of a ratio. So that's how we figure out the mass spectrum of isotopes.